So in this situation, we basically have our normal and our up telling the copied of points what to do. If I was to get rid of the 3x3 rotational matrix and the determinants right there, it all works just fine. So that's really all you need to get this working, is just those two attributes. However, let's say that I want to make this into a quaternion-based rotation. And I'll show you why you might want to do that here in a second. But to do that, we need to create the orient attributes. So at orient, set this equal to the quaternion function. And for this argument, I'm going to use a function here, make transform. There we go. So make transform needs two vectors in order to make a 3x3 rotational matrix. And if I go to this quaternion, we're basically using this first argument right here. So we're feeding it a 3x3 matrix. Make transform needs to start with your z, so at n, and let's take our up, like so. Now here's the cool thing. Anytime you specify orients, now quaternions are activated. And that's kind of the way I like to think about it in my head. It's like you just turned on quaternion mode. If I middle mouse, you could see that this is also called a quaternion, and it's specified right there. So that being the case, I can now turn all this stuff into variables, which is cool because then I don't have to save out those attributes with the GeoStream. And that makes it a little bit more optimized. And there we go. Now we're just a little bit more optimized. So let's now talk about the pros and cons between Euler versus quaternion-based rotation. Euler pros. This is our familiar XYZ rotation that you're used to seeing. I kind of picture this as the XYZ rotation handles that you're used to pulling around. And in general, it's a bit easier to understand. It's also more commonly used. If you, let's say, have some values show up in the Geo spreadsheet, you can generally tell what something is doing. So, like I said, easier to understand. But it does come with some problems. For one, gimbal lock is possible. And I'll show you what that is visually here in a second. But basically, that's when you get stuck because a couple of rotation handles overlap each other. It's also more computationally expensive when comparing it to quaternions. You need a full matrix to describe Euler-based rotation, which is a 3x3 table of information, whereas a quaternion only needs 4 values. So if you have, like, let's say, a million pieces of debris, you want to do what you need to do with as little data as possible. And that can make a big difference depending on your situation. Also, Euler angles and Euler rotation runs into a problem sometimes whenever you're trying to blend or combine rotation. So let's say that I have something that's rotated by negative 500 degrees, and I visually want to blend that with something that's maybe 30 degrees. The thing is that you basically just have rotation values that need to blend with each other. There is no sort of way for these values to visually understand what's happening. So you might be at negative 500, but in order to get to the 30 degrees positively, let's say, it needs to basically unwind itself or go all the way up to 0 and then up to 30 to get to that position. And so that's, it's a little bit easier to see, but in general, just know that sometimes you will run into problems whenever you're trying to blend these rotations. Now, quaternions, they avoid everything that I was just talking about. You don't have gimbal lock. You only need 4 values for this to work, and it's also great at blending and combining rotation. Unlike Euler rotation, quaternion kind of looks at it as a position within an imaginary sphere. So if it just has, like, if something needs to rotate in a certain area, like a certain direction, it doesn't really think of it as I'm in a negative value, I need to go positive. It kind of just says, where's this rotation along this imaginary circle that I need to get to, and it just kind of bases it on the shortest path from there. I'll show you what that looks like again here a little bit in a second. And the quaternion cons here is that it's not easily readable. If you were to pull up some of these values in the geo spreadsheet, it's not as obvious about what's going on. And it's also just generally more complex and difficult to wrap your head around. Hopefully, these lessons have made quaternions a bit more approachable, but I am definitely simplifying a lot of the stuff that goes into quaternion rotation. I'm basically just trying to show you what it can be used for. But if you actually get into the math behind quaternion-based rotation, it does get pretty heavy. So that is a con compared to Euler angles. Now, as I was saying, this is what gimbal lock looks like. Notice how this is a little sphere here that's rotating, and it's very possible for all the rings to line up like this. So if, let's say, you're in this situation and you want to rotate that way, I guess perpendicular to where these rings currently are, then you're kind of stuck because your only option is just to rotate these rings and you're basically locked in that place. So that's what gimbal lock is. If you're not familiar, it can be a problem a lot of times in rigs and just something in general that you don't want to run into. In the next lesson, let's take a look at how to blend quaternion-based rotations, and I also want to show you a few different ways in which you can use the quaternion function.